Good morning. So today I am going to discuss some more problems in what I had discussed in the previous sessions in sampling theory. So question number 6. I hope you are ready. You have read all those test of significance by proportion, test of significance, and then all the different headings, different types of tests of significance I have given. Read that and the formulas, and be ready for the solving of problems so that you'll understand more. Now here, in a sample of 500 mean, it was found that 60% of them had overweight. What can we infer about the proportion of people having overweight in the population? So again, I'll repeat it. In a sample of 500 men, it was found that 60% of them had overweight. What can we infer about the proportion of people having overweight in the population? What can we infer? See, what can we say? What can we conclude like that? What can we infer about the proportion of people, having overweight in the population? Okay. So, solution: probability of persons having overweight. So 60% means 60 by 100, that is 0.6. P equals 0.6. Why is given here? 60% of them had overweight. So P is 60 by 100, 0.6. So if P is 60.6, then P plus Q is 1. So Q is 1 minus P, that is 1 minus 0.6, that is 0.4. Now, probable limits in this significant test of significance by proportions. The formula is there. I have given the formula list. I had given the theory before, in the 2-3 sessions back, complete theory of all the significance test, hypothesis test, and then the chi-square test, etc. So in that, there is the formula. P is equal to plus or minus 2.58 square root of PQ by N. So substitute P is 0.6 plus or minus 2.58 square root of PQ, 0.6 into 0.4 by N. N is sample of 500 men. So 500. Okay, 0.6 into 0.4 divided by 500. Okay, this will be now 0.6 plus or minus 0.0565. This will be, if you multiply all of this, you will get 0.6 plus or minus 0.0565. So this will be 0.5435 when you add, and once you add, once you have to subtract. Okay, 0.6565. Two. Just check whether I am correct. Simple calculation. Now when we want it in terms of percentage, we divide by 100. So it will be the probable limits of people having overweight. Therefore, the probable limits of people having overweight is 54.35% to 65.65%. The probable limits of people having overweight is 54.35 to 65.65%. The probable limits of people having overweight is 54.35% to 65.65%. Okay. Now we go to the next question. A survey was conducted in a slum locality of 2000 families by selecting a sample of size 800. Okay. A survey was conducted in a slum locality of 2000 families by selecting a sample of size 800. It was revealed that 180 families were illiterates. Find the probable limits of the illiterate families in the population of 2000. Find the probable limits of the illiterate families in the population of 2000. So once again, I will just read it. A survey was conducted in a slum locality of 2000 families by selecting a sample of size 800. Hope you understand the sentence. It was revealed that when the survey was done, it was revealed that 180 families were illiterates. 180 families were illiterates. So find the probable limits of the illiterate families in the population of 2000. Now, find the probable limits of the illiterate families in the population of 2000. Find the probable limits of the illiterate families in the population of 2000. So how to do it? Find the probable limits of the illiterate families in the population of 2000. So now, probability of illiterate families first. Probability of illiterate families, P equals what here? Illiterate families, 180 by 100. So by 100, probability of this is 180. Probability will be equal to 180 by 2000. It is 180 by 2000. So total 180 by selecting a sample of size 800. So this will be 180 by the value, just the probability. Probability is total. Survey was conducted in slum size of 2000 families. By selecting a sample of size 800, it was revealed that 180 families were illiterate. So it should be 800. Just correct it. P is equal to 180 by 800. That you get 0.225. Okay. 180 by 800. You get 0.225. Just correct it. It is 180 by 800, 0.225, and Q is equal to P plus Q is 1, Q is equal to 1 minus P, that is 0.775. 1 minus P, that is 0.775. Now, probable limits of illiterate families, the same question like previous. The formula is there, P plus or minus 2.58 into root of PQ by N. Probable limits of illiterate families, that is given by P plus or minus 2.58 into square root of PQ by N. So it is 0.225 plus or minus 2.58 square root of 0.225 into 0.775 divided by 800. This when you calculate, you will get 0.225 plus or minus 0.038. So this will be when you calculate it, it will be 0.187 and 0.263, 0.187 and 0.263. So the probable limits of illiterate families in the population of 2000. So the probable limits of illiterate families in the population of 2000 is 0.187 into 2000 and 0.263 into 2000. So the probable limits of illiterate families in the population of 2000 is 0.187 into 2000 and 0.263 into 2000. So it is thus 374 to 526 are probably illiterate families. 374 to 526 are probably the illiterate families. Again, I repeat because some students came late. A survey was, the same question I am doing again, a survey was conducted in a slum locality of 2000 families by selecting a sample of size 800. It was revealed that 180 families were illiterates. Find the probable limits of the illiterate families. In the population of 2000. It's the question. So first we find probability of illiterate families. That is P. That is 180 by 800. Just correct it. There is a writing mistake. 180 by 800. That is 0.225. 180 by 800. That is 0.225. Then we have to find Q. Q is equal, P plus Q is 1. So Q is 1 minus P. 1 minus 0.225. That is 0.775. Now, probable limits of the illiterate families. So, probable limits of the illiterate families is P plus or minus 2.58 square root of PQ by N. So, P plus or minus 2.58 square root of PQ by N. So, P is 0.225 plus or minus 2.58 square root of 0.225 into Q value 0.775 divided by 800 total. So you get so much. This is usual calculation. Verify. I might be wrong. Just check it in the calculator. So 0.187 and 0.263. Therefore, the probable limits of illiterate families in the population of 2000 is. Therefore, the probable limits of illiterate families in the population of 2000 is 0.187 into 2000 and 0.263 into 2000. Therefore, the probable limits of illiterate families in the population of 2000 is 0.187 into 2000 and 0.263 into 2000. That is thus 374 to 526 are, when you multiply this you will get 374 to 526 are probably illiterate families, Next question. In a hospital, 230 females in a hospital, 230 females, okay. In a hospital, 230 females and 270 males were born in a year. Do these figures confirm? Do these figures confirm? Okay, do these figures confirm the hypothesis that sexes are born in equal proportion? Sexes are born in equal proportion. Some students late. Anyway, in a hospital, 230 females and 270 males were born in a year. Do these, in a hospital, 230 females and 270 males were born in a year. Do these figures confirm the hypothesis that sexes are born, sexes means male and female, are born in equal proportions? Means, do these figures confirm the hypothesis they are given that the sexes are born in equal proportions, the male and female are born in equal proportions? So solution, total number of births. First we find, I hope you understood the question. So we have to confirm, do these figures confirm the hypothesis that the sexes are born in equal proportion? Means male and female are born in equal proportions. You have to confirm by the test, that is less than 2.58, greater than 2.58, like that. Okay. Total number of births, n equals 230 plus 270. Total number of births, n equals 230 plus 270, that is 500. So observed proportion of females. In this, the females is, you can take male also. I took female. Observed proportion of females is 230 by 500, that is 23 by 50. It is 0.46. Assuming that sexes are born in equal proportion, as they are given here, see, do these figures confirm the hypothesis that sexes are born in equal proportion? So assuming that the sexes are born in equal proportion, probability of female birth is equal to half. Okay, if they are born in equal proportion means probability of female birth is half, just like tossing coin. Probability of female birth will be half. I take it as P. Probability of male birth will be again half, because P plus Q is 1. So assuming that the sexes are born in equal proportion. Why you assume? Because that is the hypothesis in the question. See the question. That is the hypothesis in the question. Assuming that sexes are born in equal proportion. Sexes means male or female. Probability of female birth is equal to half. Just like tossing the coin. It will be just like tossing the coin. The problem will be like tossing the coin. So probability of female birth is equal to half. Then, so I hope you followed that. So if P is half, then Q is also half. If P is female birth, Q will be male birth. Now difference in proportions. See, probability of female birth I got 0.5, half. Difference in proportions, but here it is given 0.46. See, observed proportion of females as given in the data. Observed proportion of females as given in the data is 0.46. So difference in proportions is 0.5 minus 0.46, that is 0.04. Now we use the formula of standard deviation because we need to find Z. So standard deviation proportion of females. Standard deviation proportion of females for the significant test on proportion. This is the formula. Look back. Square root of NPQ divided by square root of N. Square root of NPQ divided by square root of N. Okay. That will be nothing but N can be written as root N into root N. 1 root N get cancels. So it will be square root of PQ by N. So half into half divided by 500. N is 500, you know that. See here 500. 230 plus 270 is 500. Okay. So you get the answer as 0.0224. Check whether I am correct. I might be wrong. Always you should check using your calculator. Now standard deviation Z equals difference. Difference means X minus NP or difference whatever X. Different formulas, 2, 3 formulas, different way of writing the formulas. Difference divided by standard deviation. Difference is here 0.04 divided by SD, standard deviation of the proportion of females. That is 0.0224. I have done this problem taking females. You can do it by taking males, you will get same answer. So 1.786. Now to test the hypothesis, I take the standard value, that is 2.58. I have told it in the theory. So 1.786 what I get is less than 2.58. 1.786 what I get is less than 2.58. So now we get here that thus we conclude that the figures are conformal with the hypothesis. So less means it is conformal. The sexes are born in equal proportion. It is accepted. So less means the value what you get is less than 2.58 means the hypothesis accepted. What you assumed is correct. But if you get more than 2.58, I told many times, then it is rejected. The opposite take place, rejected. Yeah, now it is less than 2.58. So the hypothesis is correct. So the hypothesis is correct, right? So we can say that the sexes are born in equal proportion. Okay. So we can say that the sexes are born in equal proportion. So these are all question paper problems. Don't neglect it. Master all these questions. Okay. Next question. A die is thrown 9,000 times. Just read the question properly so that you understand the question first. A die is thrown 9,000 times and a throw of 3 or 4 was observed 3,240 times. You know a die, when playing Ludo, it has got 6 faces. A die is thrown 9,000 times and a throw of 3 or 4 was observed 3,240 times. Show that the die cannot be regarded as an unbiased one. Show that the die cannot be regarded as an unbiased one. Again, I repeat. Show that the die, see the hypothesis, cannot be regarded as an unbiased one. You have to be very careful. Cannot be regarded as an unbiased one. So it should be biased. So what we think is it is biased. Is it not? Show that the die cannot be regarded as an unbiased one. So show that the die is biased. So show that the die cannot be regarded as an unbiased. So the die cannot be regarded as an unbiased. So cannot be regarded as an unbiased means what? So that the die cannot be regarded as an unbiased means it should be biased. Okay, we'll see what it is. So understand the question properly. They have given it in the cannot be, that all these things. Okay. Now, probability of getting 3 or 4 in a single throw is, probability of getting 3 or 4 in a single throw is 3 or 4. So 2 out of 6. So 2 by 6, that is 1 by 3. Probability of getting 3 or 4 in a single throw is P is 2 by 6. That is 1 by 3. Q is 1 minus P. That is 1 minus 1 by 3. That is 2 by 3. Always P plus Q is 1. Now, expected number of successes. So, expected number of successes is, see, P is the success now. Probability of getting 3 or 4 in a single throw. It was 3 or 4 is observed 3,240 times. So probability of getting 3 or 4 in a single throw is P is 2 by 6, 1 by 3. So if P is success, Q is failure, and totally P plus Q is 1. This you know from the basics. So expected number of success is 1 by 3 into 9,000. Expected number of success is 1 by 3 into 9,000. Expected number of success is 1 by 3 into 9,000, that is 3,000. But actually observed number of success, it is given to be 3,240. Observed number of success is given to be in the question, that is 3,240. Observed number of success is 3,240. So the difference, same concept. By now I have solved many problems. You got the idea. You should have got 3,250 minus 3,000. So that is 240. Now consider the formula Z equals difference by square root of NPQ. That is x minus NP. Here we took the previous problem. Difference by standard deviation. Standard deviation is nothing but square root of NPQ. It is same. So Z is equal to x minus NP by square root of NPQ. X minus NP divided by square root of NP. Another formula. Z is equal to x minus NP by square root of NPQ. Depending on which formula to use on the given data, you have to conclude. So we get here 240 difference divided by square root of n is 9,000. P is 1 by 3 into 2 by 3. You will get 5.37. Just verify whether I am correct using the calculator. Now Z is equal to 5.37 greater than 2.58. So it is greater. Greater means what we can say, it is rejected. This hypothesis is rejected. The opposite will take place. Show that the die cannot be regarded as an unbiased one. So what we cannot be regarded as means What we can say the opposite of that? The rejected, that hypothesis rejected. So we conclude that the die is biased. So we conclude that show that the die cannot be regarded as an unbiased one. That was the hypothesis, but we got it greater than 2.5, so it is rejected. So it cannot be regarded as an unbiased one. The opposite of that take place. That is, we conclude that it can be regarded as a biased. So we conclude that the die is biased. So cannot be regarded as an unbiased one means, what is the meaning? Cannot be regarded as an unbiased means it could be cannot be regarded as unbiased. That means it is regarded as biased, is it not? So we conclude that the die is biased. We conclude that the die is biased. I hope this is little bit tricky in the hypothesis part. Just understand it properly. So greater than means rejected. The given hypothesis is rejected and opposite take place. Less than means it is accepted. Anyway, a sample of 100 days. Next question from question paper. A sample of 100 days is taken from a meteorological records, some record of where weather reports are kept. A sample of 100 days is taken from the meteorological records of a certain district, and 10 of them are found to be foggy. Foggy means what they say, the like smoke. Early morning it will be there, fog. So 10 of them were found to be foggy. What are the probable limits? What are the probable limits of the percentage of foggy days in the district? What are the probable limits of the percentage of foggy days? What are the probable limits of the percentage of foggy days in the district? So again, a sample of 100 days is taken. A sample of 100 days is taken from meteorological records of a certain district. A sample of 100 days is taken from meteorological records of a certain district, and 10 of them are found to be foggy. What are the probable limits of the percentage of foggy days in the district? So P is let us take P as the proportion of foggy days in a sample of 100 days. Proportion of foggy days in a sample of 100 days. That means given by 10 were foggy out of 100. So 10 by 100, 0.1. So Q will be 1 minus P, that is 0.9. This I can be a little faster. So probable limits of foggy days. This probable limits formula is there, P plus or minus 2.58 square root of PQ by N. What are the probable limits question? Probable limit formulas already I've used it in the first question today. That is might be question number 7 or so 8. So this is the formula. See the notes what I had given, that is there to find the probable limits. The formula is P plus or minus 2.58 square root of PQ by N. So the probable limits of foggy days is equal to P plus or minus 2.58 square root of PQ by N. So P is 0.1 plus or minus 2.58 square root of 0.9 divided by N is 100 days. N is 100. So I'll get 0.1 plus or minus 0.0774, 0.0226 and 0.1774, both the values. So we convert it to percentage, divide by 100. This will be 2.26. This will be 17.74%. Thus, the percentage of foggy days lies between 2.26 and 17.75%. Thus, the percentage of foggy days lies between 2.26 and 17.74%. Okay, next question. An unbiased coin is thrown n times. It is observed that the relative frequency of the appearance of heads should lie between 0.49 and 0.41. Again, I repeat, an unbiased coin is thrown n times. It is desired that the relative frequency of the appearance of heads should lie between 0.49 and 0.51. We'll see how to use it. Find the smallest value of n that will ensure this result. So find this is a different type of question, very old question of a problem also. Find the smallest value of n that will ensure this result with A, 95% confidence and B, 90% confidence. Find the smallest value of n that will ensure this result with A, 95% confidence, B, 90% confidence. So probability of getting a head, P is equal to half, because coin, you know that Q is 1 minus P, that is half. Then standard error of the proportion of a standard error formula. See the standard error formula in significance of proportions. Square root of PQ by n, that is square root of half into half, that is 1 by 4 into n, that we can write as 1 by 2 into 1 by root n, or 1 by 2 root n. Now A, probable of 95% confidence. The probable limits of 95% confidence level is given by the formula back. See the notes back. P plus or minus 1.96 square root of PQ by n. Probable limits of 95% confidence level is given by P plus or minus 1.96 square root of PQ by n, which should be as given in the question. It should be between 0.49 and 0.51, 0.51 and 0.49. Okay. Now I substitute the value 0.5 plus or minus 1.96 by 1 by 2 root n. Root PQ by n is 1 by 2 root n. Okay. Is 0.51 or 0.4. Now take any one value. Both value need not. One plus value, one minus. Both answer will be same. Take any one value and solve. Both are same. I will solve one. See, 1.96 by 2 root n is 0.51 minus 0.5, the 0.01. Or root n is 1.96 by 0.02, that is 98. Or n is square of 98, that is 9604. Even if you take other case, here also it will be same. 1.96 by 2 root n will be equal to 0.5 minus 0.49, that is 0.0, and again you get same answer. Okay, now we go for 90% confidence intervals. Here the formula is different. Here it was 1.96, here it is 1.645, rest everything is same. For 95%, the formula is P plus or minus 1.96 square root of PQ by n. For 90%, it is P plus or minus 1.645 square root of PQ by n. So doing in the same way, only change will take place here. 1.645 by 2 root n equals 0.0, and everything is same. Just you put here in place of 1.96, you put 0.645, 1.645. Same thing, so 0.01. Okay, so calculate n, you will get 6765. Hope it is clear. So for 95%, it is P plus or minus 1.96 root of PQ by n. For 90%, it is P plus or minus 1.645 root PQ by n. See the notes I have given it. Then everything is as it is. So you get the answer as n is 6765. So this type of, you have to solve the question, this last question, just you have to be careful here. See, an unbiased coin is thrown n times. It is desired that the relative frequency of the appearance of head should lie between 0.49 and 0.51. Find the smallest value of n that will ensure this result with 95% confidence A and 90% confidence B. Is it not? Now, first you probability of the coin getting head half, Q half, and then standard error of the population of heads, root PQ by n. This is also simple for you. Now this formula you have to remember. For 95% confidence level, it is P plus or minus 1.96 root PQ by n. And for 90% confidence interval, it is P plus or minus 1.645 root PQ by n. I have given in the notes, just see that. I have done it directly. So this is equal to the two given values, either this first or this first, anything. So plus I can take this, or plus I can take this, or minus, whatever. You take it, you will get same answer. One I took, you can take for 0.45, you will get the same answer, n as 9604. The answer will be same. Okay. Now, for the 90% confidence interval, the formula will be P plus or minus 1.645 root PQ by n. So same way you calculate, it will be 1.645. In place of 1.96, it will be 1.645. So the same thing it is. So we get here 1.645 by 2 root n is equal to 0.09. 2 root n is equal to 0.01. Why 0.01 means same step, 0.5 plus or minus 1.645, 1 by 2 root n is 0.51 or 0.49, like that. So the next step, it will be 0.5 plus 1.645 by 2 root n is 1.51. Next step, it will be 1.645 by 2 root n is 0.01. That only I have written here directly instead of wasting the time. So root n will be 1.645 by 0.02. 1.645 by 0.02. That is, just check it, I might be wrong, 82.25. Then n will be equal to square. 82.25 squared, you get so much. So you have to, because it is n is the number. What is it? N. thrown n times. So we cannot throw 1.5 times. N should be an integer. So we round it off to 6765 because it is 06. More than 5 after decimal place means we can take to the next highest number. So n is 6765. So this last problem, please practice it. It is very important. Now, since the time is up, once again, as frequently I am telling, write the notes, update your notes, and then do all the assignments in the way what I have said. Assignment 1, the questions I have given in the class, solve it. Then the question paper I have sent, solve it in a separate book, all those things. Then you go through the notes, solve the solved problem, see the model question paper, try to solve it. Okay, be ready for the exams. Okay, when the college starts, any doubt is there, you can ask me, and still any doubt is there, you can pick the place where the doubt you can ask me later. Okay, so we'll continue with some more problems in the next session tomorrow. So I wind up the session now. All the best. Thank you.